Alright, in number 5, we're asked to find the tension in the ropes and the acceleration of the blocks. So actually what I'm going to do, I think I'll find the acceleration of the blocks first. Gravity pulls down on this at 196 newtons. And gravity pulls down on this one, you take 15 times 9.7 and you get 147 newtons. Like so. Now, this block pulls up on this one at 147, and then this big block gets translated over and it pulls up on this one at 196. Now, to find the acceleration of the system, F equals ma. Now you have the two forces. We could look at either one of the. You can take 196 minus 147 or 147 minus 196. The mass, it's actually both of these blocks which are accelerating. So you have to use the mass of both of these blocks, 35 times the acceleration a. And you solve that and you get 1.40 meters per second squared for the acceleration. Now, what that's saying is that this block accelerates this way at 1.40 meters per second squared, and this block over here accelerates up at 1.40 meters per second squared. Now, part 2 says find the tension. The tension in these two strings are the same. Now, it can't both be 147 and 196. For instance, it can't be 147 because if the force over here was 147, then this would work. There's more downforce than up, so then it definitely would accelerate down. But then you look over here, the downforce equals the upforce, and that doesn't give us an acceleration. And likewise, they can't both be 196 because then you'd have the same over here. If you added them, sometimes people say, whoa, I bet I just add these forces together, and that's what gives me, that's the tension. So you add these two and you get 343. But look at the big block. It doesn't make sense that this pulls down at 196 and up at 343. How can it be accelerating down when the up force is larger? And then other people go the other way, and they're like, what if you subtract them? No, if you subtract them, the opposite happens. You subtract them, you get 49. If you subtract them, you get a bigger downforce, but then over here you have a bigger downforce, and it can't accelerate down. So the problem becomes, it actually is in between. It has to be, the tension has to be in between 196 and 147 because let me just grab you a number in between them, like 160. So if this is 160, you have definitely more acceleration, more force down here, so this one could accelerate down. If this is 160, there's more force at the top, so it could accelerate up. So 160 could possibly be the answer. But how do you find exactly what it is? To find exactly what it is, let's just give it a variable. I'll call it the force of tension. It's the same in both cases. Now, instead of looking at the whole thing, I'm only going to focus on one of my blocks. In one of my blocks, I have a down force and an up force. So F equals ma. I've got a down force 196, and I've got an up force, the tensile force. The mass is only this block, 20, and the acceleration I know is in this direction, 1.40. So 20 times 1.40. I subtract 1.96, multiply by -1, and the tension comes out to be 168 newtons. Now, I could have done the exact same thing over here. I could have looked at just this block. F equals ma. The two forces. I'm going to call up positive in this case. I've got a positive force, force of tension. I've got a negative force, 147. My mass is 15, and the acceleration is up in the positive direction, 1.40. So 15 times 1.4, I add 147, and believe it or not, it comes out to the same thing, 168 newtons. So, in summary, to find the acceleration of the system, you've got to use the mass of both and the forces of every action is an equal opposite reaction. You also, then to find the tension, you have to look at only one of the blocks. And it doesn't matter which one, both will come out evenly.